Now I'm going to move further down here. So here's the change gears, and these operate off this little gear which is locked onto the spindle. Again, this is just located onto a flat on the spindle and is linked to this gear via a small pin. If I've got my, I've lost. There's just a small pin that locates onto that, and there it is. So you can see here, here's another one for the lead screw, and I will have to re-drill or make another one of them. It's not right clever, but that locates onto a flat on the lead screw. The pin goes into the gear, and there's holes drilled into the gear, so that will then go in, lock up tight, and everything. All these change gears here rotate, locking, meshing together, which then drives this gear, which is then through this pin and grub screw is linked to the lead screw. Now when I first got the lathe, there were shims mounted behind here which was pulling everything this way, which obviously meant that all these gears were out aligned that way. Not by much, but enough enough that I was not happy with it. So I've taken the shims out, mounted that back in where it should be. Unfortunately, the disadvantage of that is at the back here it's worn a taper into the casting. So I mean that can be fixed with a bush in there, reamed out, and a sleeve fitted into there. However, it's not so critical at the moment for what I'll be doing with it. I don't intend on doing any thread cutting. I'm simply going to be using the lead screw for fine feed. So the change gears as well at the moment are not really too essential to what I'm planning on using the lathe for. If we just go inside here, if I can get the camera to focus inside there. So at the back there you can see the bronze half nuts, and that's simply operated by this lever on the apron. If it was in the right place, and a dial indicator there, that tells you whereabouts you need to be for the half nuts to engage properly. So once that's lined up on a number, your lever drops down, your half nuts engage, and this lever then can traverse this apron saddle assembly. As you can see, it's a lot better for fine feeds, and it also gives you a bit more torque when turning the handle as opposed to turning this handle. When you turn the handle on a lead screw, you get a lot more force behind it and a smoother motion as opposed to turning this handle, which I'll just unlock that a minute. Turning this handle, because I've got the thing so tight, it's not a very steady movement, so trying to feed that in by hand and keeping a steady motion is not the easiest thing to do. The gibs on this saddle, you've got three in the back. You have three adjusters at the back, so just a slotted grub screw and a locking nut, and those simply adjust in and act onto a metal piece that's just locks onto the back of the dovetail there, and that takes up your forward, backwards, side to side play. Again, grub screws that run along here that you can see, they've all been adjusted pretty tight so that there's no slack. So what was happening was it were all doing this. Those have been adjusted as tight as they can go while still allowing movement, and they're a lot better than what they were on all of the handles. It's stiff, but it's certainly a lot tighter than what it was, and I know people say it should be nice and smooth, but unfortunately on such an old lathe like this you're not going to get the same smoothness as what you would do on a Chinese lathe or something similar. At the back here I've got a parting off tool. It's an old design, it came with the lathe. you've got the parting off tool there, which should face in the opposite direction. So normally your spindle's rotating anti-clockwise, and you'll have this tool in place, which is cutting up into the direction of the workpiece coming round. Now on the opposite side, you need to reverse your tool and turn it upside down, because the rotation, the workpiece is going to be coming into the tool that way, as opposed to be coming downwards. Your forces are now acting upwards, which is good on an old lathe for parting off, because it means that if you have got any wear in the saddle, it's not going to bounce around and cause vibration. On here I've got a 4-way tool post, so you undo this nut with a nice little wrench. That pin in there, that's a locating device, so you pop that up with a flat blade screwdriver. This whole assembly can then rotate around to where you need it, and that locates it square on to the compound slide. So if we come to the back of the lathe, we've got the nice trusty ML4, well, Myford ML range tailstock, which is a slide over tailstock, which means there's no location from the casting to the bed as to where it should align. You have a clamp at the back, which is a quick release clamp, a bolt there to adjust what angle that clamp acts onto the dovetail underneath, and you have the gibs at the front. This in the centre is a locking device, so I can lock underneath here. There's a plate which can be bolted and drawn up to the bottom of the saddle, bottom of the weighers. So these screws at the front, you've got the 2 gib adjusters here, where again with locking nuts, and then you've got 2 bolts here which actually bring the gib up and down and tighten that against the dovetail underneath. Now the spindle, I'll just show you this. We've got 1/8 hour play in that poor little spindle. It's not good. It's not for drilling a hole. You don't want it bouncing around like that. So one thing we've found is obviously nipping it up, just literally enough to put some pressure on there. You can still turn it, and you can, if it's really hard going, you can tighten it up a bit more. But yeah, this will need boring out and a sleeve putting into here to around about here, which is just past where the clamp acts. So we'll bore that out around about 1 inch deep, make up a sleeve to fit down the bore that we've made, and the internal diameter will be the same as the quill diameter. It can be fixed, but it's going to take a bit of time. On the back here as well, you can see the movement in the handle. So what's been suggested by Fraser is to take this off. There's 2 slotted grub screws, two slotted screws there, and a little dimple. If I can view from the back, it might be easier. So you can see the casting has a cut out there to allow you to get a screwdriver in. But to take this handle off, mount it in the chuck, clock it in so that this outer face here is running concentric on the lathe, and then machine the little slot which is just underneath these 2 clamp pieces here. Machine that slot so it's just undersized and nice and round, and then make up 2 new brackets to hold that in place, which will be a tight fit against the new machine surface, and then that will get rid of all of that. So by the end of it, the amount of movement that we have will just be on the thread itself, so basically backlash. Thanks for all having a look round. I'll put kettle on, let's have a cup of tea.